Optional extra practice from Chapter 3, Section 4 if needed. Use the rational zero theorem. We might not remember what that is, but it tells us to list all possible rational zeros of the function. So that's where we decided that the constant is p, at least the absolute value, and the coefficient is q. I think I'm going to start doing the factors of p up here. Factors of 16. So positive, negative, 1 goes in, 2 goes in, 4 goes in, 8 goes in, and 16 goes into 16. Factors of q. Factors of the lead coefficient, that comes from the lead term. Factors of 2. Positive, negative, 1 and 2. All right, so we're going to take every p and put it over every q. So I'm going to just start with the entire p list, putting it over 1, each and every one of these factors over 1. So that just results in the same list, 1, 2, 4, 8, and 16. Then I'm going to take all 5 of these numbers and divide them by 2. So 1 over 2 is a half, and I don't have a half, so I have to record it. 2 over 2 is 1, I have it. 4 over 2 is 2. 8 over 2 is 4, and 16 over 2 is 8, so I do have it. So I have got my entire possible rational zero list. And that's all we're asked to do, not find the zeros. The language of the question is to use the rational zero theorem, list all possible rational zeros, not find any, just list them. All right, we've got P and we've got Q here in our second example. So I'm just going to go right to factors of 3 and factors of Q. 1, 2, and 4. So I'm going to take 1 and 3 and put each of those over 1. So 1 over 1 and 3 over 1. Then I'm going to take 1 and 3 and put them each over 2. So 1 over 2 and 3 over 2. And then 1 and 3 each over 4. So 1 over 4 and 3 over 4. All right, in the next two examples, we're asked to find all the zeros or the roots for the following functions using these steps. So first, let's find all the possible rational zeros by doing what we did up here. And then we use synthetic division until we find the first zero. And then we set the remaining factor equal to 0 and solve for x by factoring or using the quadratic formula. Okay, so let's see. This is P and this number 1 is Q. So I think I'll come up here and create my P over Q list. Well, seeing that Q is just 1, then the factors of P are actually just going to be my P over Q list. So I have 4 numbers, both positive -1 and positive -13. So step 1 done. Step 2, let's just start with positive 1. Synthetic division. That looks funny over here. Oh, I got lucky. So remember, these are the coefficients of the third degree problem, and then these remaining coefficients are the coefficients of the quadratic. So far, I think I'll come over here and start a zeros list. So x equals 1, because it gave us a remainder of 0. All right, so this quadratic factor can be set equal to 0. This won't factor, so I'll have to go to the quadratic formula. A is 1, B is -4, and C is 13. So opposite B, plus or minus. Here's your conjugate pairs of irrational zeros. 14 minus O. I think we've seen this one. Negative 36. I know this will produce an I, and then if our attention focuses on the square root of 36, that's just 6, so 6I. I'll come up here. I see that 2, 4, and 6 all can be divided by 2, so 2 divides into 2 once. That leaves a 2 here and a 3 here. So we get x equals 2 plus or minus 3I. So I'll write those out separately over here. So 2 minus 3I and 2 plus 3I. Those are our imaginary conjugate pairs. So we have 1 rational 0 and 2 imaginary zeros for a total of 3, and it should match the highest degree here, the degree of the polynomial. So let me go back and make sure I've answered the question. Find all the zeros for the following functions using these steps. Yep, we did. All right, so we have a cubic. We're going to have 3 zeros. Let me get my P over Q list. So this is P and this is Q. It's a little more complicated, so let me find the factors of P. 1, 2, and 4. Factors of Q are 1 and 2. So P over Q. So 1, 2, and 4 all go over 1, so that's just 1, 2, and 4 again. And then 1, 2, and 4 will go over 2. So 1 over 2 is a half. 2 over 2 is 1, I got it, and 4 over 2 is 2. So we've got our list here. All right, I guess I'll just start with positive 1. No zeros need to be filled in here because all terms are present. Ooh, this doesn't look good. So negative 9, no, that won't give me 0. So I guess I'll try negative 1. Nope, that's not 0 either. Okay, so I've got to move on to 2. Try that next. Try negative 2, try 4, negative 4. And actually, I've tried these, and I will tell you we'll save some pain here, that 1/2 is a 0. So we're going to do the 1/2 next. Two times a half is 1. This is negative 4. Times a half is negative 2. The sum is negative 8. Times a half is negative 4, and that is our 0. So let me get a 0 list going over here. So because I have a remainder of 0, x equals a half is the 0. And we need 2 more. So remember, these are coefficients of a cubic, and these are coefficients of a quadratic. We'll come up here. So 2x squared minus 4x minus 8 equals 0. You can do factor by grouping here, quadratic formula. There's also something else we can do. I see that 2 can divide out of each of these terms. That way I can focus my attention on, is this an easy factor? Yes, it is. I'm not going to use quadratic formula. This is an easy factor because now a is 1. So I look for factors of negative 4 that sum to negative 2. Oh no, that's not going to be an easy factor. That won't factor. So let me backtrack. Sometimes that happens. So forget this, forget this. I'm going to go right to quadratic formula. You can do factor by grouping. I'm just going to go right to the quadratic formula. So I've got a, b is negative 4, and c is negative 8. So negative 4 squared minus 4 times a times c. all over 2 times 2. This is 16 plus 64. That's going to be 80. Ugh. I won't have an imaginary solution, but I will have an irrational solution because this is not a perfect square that pops out. So plus or minus. I do know that 80 is 16 times 5. So the square root of 16 will come out as a 4 here. That 4 is in the denominator, leaving 5 in the radical. Let me come up here. I see that the numbers 4, 4, and 4 all can be divided by 4. So 4 divides out of 4 once, 4 goes in here once, and 4 goes in here once. So I don't need the denominator of 1. So I've got 1 plus or minus. Oh, I'm kind of encroaching upon my 0 space here. Come down here. X equals 1 plus or minus square root of 5. So I have 2 more zeros. 1 minus square root of 5 and 1 plus the square root of 5. Notice these are irrational conjugate pairs, and they always occur in pairs irrational zeros do. So 1 rational and 2 irrational zeros. Okay, continuing with more practice, there's 2 final problems. All right, find an nth degree polynomial function with real coefficients satisfying the given conditions. So the degree is 3. We want a cubic. We have 2 of the zeros here listed, and then we have this additional information. So remember, we're going back to the function. We're doing the reverse of what we did here. They're giving us this, and we have to build the equation that these are zeros of. All right, so third degree, I first list, set each of the zeros equal to x. So x equals 1, 5i. Imaginary zeros occur in pairs, so it has to be negative 5i. We'll use this information a little bit later on. We set up the f of x notation with the a subscript n next, and we built 3 parentheses. X equals 1 comes from the factor x minus 1. X equals 5i comes from x minus 5i, and then likewise x plus 5i. We kept writing down f of x and a sub n. We noticed that we'd probably multiply these 2 binomials first, keeping x minus 1. Conjugates have those special multiplication characteristics, so just the first term, x squared, and the last terms, minus 25i squared. We don't want imaginary numbers in here. We want real numbers. So my attention is still here. I squared can be replaced with negative 1 to be multiplied by negative 25. So that'd be x squared plus 25. We continued multiplying the next 2 binomials together by foiling. So multiplying these 2 together. X cubed, 25x minus x squared minus 25. I think I took the time to kind of rearrange here or collect. So cubic and then quadratic comes next. Linear with the exponent of 1 and then the constant term. Okay, not quite done. We've got to remember, find a value for a sub n. That's where we go back up here and use this additional given information. Remember, this is x and this is y. So all these x's will be made negative 1s, and the y, which is f of x, will become the negative 104. It's real easy to make like a mistake here with these numbers. So just be real careful. Use your calculator. All right, and let's see what all of that results in. Hopefully something that divides nicely into negative 104. Otherwise, I probably made a mistake. Yep, negative 52. So now let's divide negative 52, negative 52. So a subscript n, and this is actually going to be a positive 2. Almost there. F of x equals, see, my last cleaned up line was right here. So f of x equals 2, and then this polynomial. And likely we're going to want to distribute that 2 inside to all the terms. All right, depending upon your comfort level, if you want to try the next one, go ahead and then just look at the solutions, the attached PDF. But if you need to hear the words, then continue along with me. Fourth degree Taylor polynomial. Oh my gosh, I can't believe I said that. I'm thinking BC, so sorry. Fourth degree polynomial function. BC meaning my BC calculus class. Too much math today. All right, so we want a fourth degree polynomial function. I is a 0. That means x equals negative I, 3i, and then the one that's not present is the negative 3i. We'll use this information later. Go to f of x, a subscript n, 4 zeros, 4 parentheses. 4 factors. It's not as bad as it seems. Keep the a sub n. We're going to multiply these 2 conjugates together and these 2 conjugates together. So here we're going to get x squared minus I squared. And the multiplication here gives x squared minus 9i squared. Let's take care of those I squareds first, converting them to negative 1s, and then finish multiplying. So x squared, this is negative 1, so minus negative 1 is plus 1. And this becomes negative 1 multiply into a negative 9, so x squared plus 9. Okay, foiling now, because these are not, they don't have a special multiplication characteristics because they're not conjugates. So let's FOIL. X squared times x squared is x to the 4th. There we go, 4th degree. 9x squared. 1 more x squared. And then a plus 9. I see we can combine these two, so we better do that first. That's 10x squared plus 9. All right, now it's time to find a sub n. How do we do that? Oh yeah, go back up here. We've got our x and y values. Plug in 20 for y and negative 1 for our x. So 20 equals 10. I want to say that's 20. I instead of using a multiplication dot, I just did parentheses again. It doesn't matter. It just means multiplication different ways. So divide by 20. So that's nice because that'll just be 1 over there. So a subscript n is 1. I'll just come back up here. So f of x equals, well, that's just a 1. Oh, that's nice. If that's just a 1 times, so here is, I guess we're right here. If a sub n is 1, then I'm not even going to write it down. I'm just going to re-record that 4th degree polynomial. So actually, that was a little bit better. Saved me a step at the end because a subscript n was just 1. All right, hopefully this review helped.